Hello, 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 and welcome everybody. Happy Tuesday. Today's the day. Mixed number multiplication. How did that happen? Oh, you know what it was? It's because I reused that thing for the other thing. Disregard, you'll need the usuals. We'll do that later with the materials to the right there. I reused it on our whiteboard slide. You'll see it later. And I didn't realize it changes it everywhere. So there we go. We're off to a great start. Here's the I cans. Those are still legit. I can use an area model to visualize and solve mixed number multiplication expressions, and I can define partial products. Materials, you know what you need. Something to write on, something to write with, obviously. Here we go. So mixed number multiplication, I think in a lot of ways, feels like the final boss battle, right? If you play a video game and you were to try and fight the final boss right out of the jump, right? What's going to happen? You're going to get crushed, incinerated, blown to smithereens, and it's not going to be a whole lot of fun, and you're probably not going to want to play that game anymore if you just immediately get in and get pwned, right? So what we need to do, and what video games do really well, story-based video games, is they let you accrue skills over time. You learn this thing, you learn this thing, you learn this defense, you learn, right? And over time, you get yourself ready to fight the final boss. And that's kind of what we've done here with multiplying fractions. And mixed number multiplication is kind of our final boss because we've got a lot of skills that we need in order to multiply two mixed numbers. But we've learned all those skills. And in fact, I wrote them all down just to show us how far we've come here, right? So we've got using area model for multiplication, whole number times fraction, fraction times fraction, converting improper fractions to mixed numbers, finding common denominators, adding fractions. All of these things we have to do in order to multiply two mixed numbers. But you've been working so hard over the last year and in fourth grade for area model of multiplication that you've got all the skills you need. You've got the right potions in your potions bag. You've got the right magical spells that you've learned. You've got the right weapons. You've got the right armor on, right? You are ready to fight that final boss. And today that final boss is multiplying a mixed number by another mixed number. So let's get into it. We're going to start with this one, 2 1/3 times 2 1/4. And wherever my marker went. And what we're going to do with this is, again, we're going to start with this idea of an area model. And this is why I had us review yesterday how to multiply a two-digit number times another two-digit number using an area model, because we're going to use it again today. Where did my marker go? Jean, what? Guys, Jean stole my marker. Hold on. We're going to go. Jean, come here. Excuse me. Hey. Where's my marker? What the heck? What? Come on. Really? I needed this. You're making me look bad in front of the kids. What are you doing here? Ugh. Sorry. Jean's killing me. Anyway, we're going to go with 2 1/3 times 2 1/4. And let's think about this because we have two mixed numbers, right? A whole number plus a fraction. Okay? When we have a whole number plus a fraction, we can break this up and separate the whole number and the fraction just like we can a two-digit number, right? So we could make Jean. Gave me a marker that doesn't work. Jean, I swear, if this you are ruining math right now. If this one doesn't work, I tell you, he's literally the worst math assistant ever. Finally, you do something right for once. Okay. 2 1/3 times 2 1/4. If we make a rectangle, right? Thinking about the same thing, area model. The area inside is equal to the length times the width. Okay, so we can separate one side into the length of 2 plus 1/3. And we can do 2 plus 1/4. And by finding these 4 partial products, 2 times 2, 2 times 1/3, 2 times 1/4, and 1/3 times 1/4, then we add them together to get our total product, just like with whole number multiplication. Gets a little more complicated though, as you can see. 2 times 2 is 4. 2 times 1/3. Okay? If it's helpful to give this whole number 2 a denominator, you certainly can. You can do 2 wholes, or 2 whole ones, times 1/3, and then multiply straight across. 2 times 1 is 2. 1 times 3 is 3. 2 times 1/4. Another way you can think about it is 1/4 plus 1/4, or 1/4 2 times. 1/4 plus 1/4 is 2/4. And lastly, 1/3 times 1/4. Right? This is we're separating one section into fourths, one section into thirds. How many do we have? How many pieces do we have total? 12, right? Just like our multiplying our denominators. And then 1 times 1 is 1, because we're taking 1/4 of 1/3, or 1/3 of 1/4. So we have one piece. So now, let's think about this. We have all of these partial products we've got to put together. So we have 2 plus 2/3 plus 2/4 plus 1/12. Oh boy, okay. Now, this is where our other skills come into handy, right? Finding these common denominators. I've already seen in the chat, they can all have the denominator of 12, right? Thirds and fourths, 3 and 4 are both factors of 12. So we could do it that way. We could say 2/3 equals how many twelfths? What do we have to multiply to get from 3 to 12? 3 times 4. So we also multiply times 4 on top. It's very, very tiny, so you can't see. Zoop! There it is. 2 times 4 is 8. So we can erase and replace our 2/3 with 8/12. Okay? Then 2/4 equals how many twelfths? How do I get from 4 to 12? 4 times what? 4 times 3. So essentially we're multiplying by 3/3. Equivalent of 1 doesn't change the value, just changes the size of our piece. 4 times 3 is 12. 2 times 3 is 6. So we know 2/4, or 1/2 for you smart cookies, is equivalent to 6/12. So we can erase it and replace it. So now we have 2 plus 8/12 plus 6/12 plus 1/12. Let's add up all of our twelfths. 8 plus 6 is, or 8 plus 2 plus 4, if you want to do it that way to make it 10, equals 14. 14 plus 1 equals 15/12. Okay, and don't forget about our 2. 15/12 plus 2. Are we done yet? No, not yet. Let's convert that improper number, or improper fraction, into a mixed number, because we have more than 12/12. So we can make a 1, right? If 12/12 equals 1, then 15/12 equals 1, and how many 12ths left over? If I have 15 pieces, I take 12 of them away and put them into a new group. How many do I have left? Right? 1 and 3 twelfths. So then I add that to my, where did I get the 2? Great question. Where did I get the 2? You know why? It's because 2 times 2 isn't 2. It's a 4. Goodness gracious. You know what? I'm going to blame Gene for that mathematical error, for that calculation error. So now we have our 15 twelfths, which we can erase and replace as 1 and 3 twelfths, plus 4. So let's add our whole numbers. 4 plus 1 is 5, and 3 twelfths. And if you wanted to reduce that, because 3 goes into 12 evenly, right? You could divide by 3 over 3 and end up with 5 and 1/4. Both answers are mathematically accurate. Okay. Should we try one more since I botched that one royally with my 2 times 2 equals 2 nonsense? Let's try one more before we go. Well, we'll jump to our whiteboard because we've got one ready to go. All right. On our digital whiteboard, our problem is going to look like this. 3 1/8 times 4 2/3. And I've put sort of the 4-step process there up in the top right-hand corner. So starting with setting up your area model, then find your partial products. After you've got your 4 partial products, before you can add them, you need to make sure that any fractions you've got have a common denominator. Okay? And if your partial products are an improper fraction, you might consider making it a mixed number before you add. Might make it a little easier to add whole numbers and proper fractions. You don't have to at that stage. You could leave it as an improper fraction and then add it and then make it a mixed number at the end. It's actually kind of a matter of personal preference in that regard. So let's give it a try here, starting by setting up our area model. We have 3 1/8, and we have 4 2/3. So now let's find our 4 partial products. This would be 3 times 4. This would be 4 times 1/8, right? Because this length here is 4. This length here is 1/8. This would be 2/3 times 3. And then this would be 2/3 times 1/8. Go ahead and try that. Some of us starting to dump answers in the chat. If you don't want to get spoiled, don't look at the chat. Keep working. Give you another 30 seconds or so to work on it on your own, and then I'll start filling in right behind you. All right, let's start with our whole numbers. 3 times 4, 12. 4 groups of 3 or 3 groups of 4. 4 times 1/8, right? 1/8 plus 1/8 plus 1/8 plus 1/8. 4/8. And somebody said in the chat that does reduce to 1/2, right? 4 out of my 8 pieces means I'm halfway there. I'm halfway to 8. Okay. 2/3 times 3. So 2/3 plus 2/3 plus 2/3. 2 plus 2 plus 2 is 6. And we're still in thirds, so we're going to leave it as 6 thirds. Lastly, 2/3 times 1/8. We'll go straight across here. 2 times 1 in the numerator is 2. 3 times 8 in the denominator is 24. I'm going to write my partial products down here in green, just to make it a little easier to see. So we end up with 12 plus 4/8 plus 6/3 plus 2 24ths. Okay, so that's going to get us our total product. Now, here's where, once you have your 4 partial products, okay, it's a good idea to pause briefly and think about, can I make any of these fractions easier to work with before I start finding common denominators? Okay, because if I were to just kind of multiply all those together, right, I'd end up in 24ths, but I'd end up with a lot of 24ths. And I bet there's a way we can work smarter here. Because I'm looking at this 6/3. And I'm thinking about, wait a minute, well, 1, that's an improper fraction. I know that's greater than 1, because 6 is greater than 3. I also know that 3 times 2 is 6. So if I have 3/3, that would equal 1. So 6/3, if I draw it out here, there's 3/3. 1, 2, 3, 4, 5, 6/3. Well, that just equals 2 wholes, right? And I'm a heck of a lot more comfortable with, I'm a heck of a lot more comfortable with whole numbers than I am with fractions. So I'm just going to erase and replace this and make this 2. That's 1 less fraction I have to work with, right? Sweet. Okay, now, are there any other fractions I could make easier? Well, 4/8 we already talked about. I could make that 1/2, right? If I have 4, or if I have I'll draw the fractions bar out here. I have eighths, 1, 2, 3, 4, 5, 6, 7, 8, and I have 4 of them. Right? I have 4 pieces shaded in, 4 pieces not shaded in. So the total value of my fraction would be 1/2. So I can erase and replace this as 1/2. And then what about my 2 24ths? Now I know both of those numbers are even. So if I divide them both by 2, or I divide by 2 over 2, our equivalent of 1, I can make that even smaller. I can say 2 24ths divided by 2 halves, which is our equivalent of 1, so I'm not changing the value again, I'm just resizing the pieces. 2 divided by 2 is 1. 24 divided by 2, or 2 times what is 24? That would be 12. So 2 24ths is equivalent to 1/12. So I can rewrite that as 1/12. These look much easier to work with than they did previously, yeah? Now, let's add our whole numbers. Let's go 12 plus 2. 12 plus 2 is 14, right? So now I have 14 plus 1/2 plus 1/12. And how many 12ths would 1/2 be? 1/2, I'll put it down here, times what is going to get us 12ths? 2 times what is 12? 2, 4, 6, 8, 10, 12. 2 times 6 is 12. So 6/6 is going to be my equivalent of 1. And 1 times 6 in the numerators is 6. So 1/2 is equivalent to 6/12. Now that I have common denominators, I can add my 6 plus my 1 to keep my 14 and 7/12. Okay? You might have got an equivalent answer. Maybe you got 14 and 14/24, for instance. That would still be accurate, because 7/12 is equivalent to 14/24. So I'd accept that answer. It's a little easier if you can reduce it, but again, we're not super pushing for that just yet. All right, exit tickets should be up now. This one was a tricky one. This example I showed was a tricky one. Some of them aren't as tricky on the exit ticket. So remember, those are our 4 steps right over there. Okay, set up your area model and find your partial products. Then think about and put all of those skills together of what's the best way for me to add these up. Do I make mixed numbers first? Do I try and make whole numbers first? Do I just find a common denominator between all of the fractions and add them up and then convert to a mixed number at the end? Okay? Different mathematicians work in different ways. As long as we're sticking to those rules of, in order to add a fraction, the denominators must be alike. And in order to convert a mixed number to a fraction, or a fraction to a mixed number, we've got to make sure we know how many pieces make a whole, so what's in our denominator. Okay, as long as we're adhering to those rules, there are different paths we can take to get to the same answer. Okay, and you've got plenty of mathematical skills to make an attempt and make it happen. Okay, it definitely won't be easy at first because this is new. Okay, but you've got the skills to make it happen, and you've got the ability to put in the work. And if you have questions, the office hour will be open in about 6 minutes, so come ask me about it. All right? Thanks, everybody, for tuning in. Good luck on the exit ticket. Come see me if you have any questions, and I will see you soon.